Hello, we are team number 1. Our term project title is Virtual VITON. Our members are Wonjung, Sun-chan, and Yujin, and we are going to present by this order. The basic idea of virtual trion is following. It has input with model and cloth, and VITON system synthesize the output model wearing the target cloth. Basically, it is by supervised learning, aiming for a natural virtual trion retains models' properties such as pose, face, and other clothes, and so on. Our replication model is CP-VITON. The title is Two-R Characteristic Preserving Image-Based Virtual Trion Network by Bo-Chang Wang et al., published on ICCVW 2018. It consists of 2 steps of network. The first network is GMM. The input of GMM is model's information with head, pose, and body, and cloth. It makes the output warped cloth, which fits to model's pose. This warped cloth is used in second network, TOM. TOM's input is model's information including head, pose, and body, and warped cloth. And finally, it synthesizes the final output model wearing the target cloth, like this. We use data, so-called Zalando dataset. It consists of 16.3K pairs of cloth and model. We used 14,221 number of train set and 2,032 number of validation set. Basically, it consists of frontal view cloth and model. And its cloth and models are matched with the same index. So you can see this model wearing the cloth of the same index. Our replication method is based on official open source of CP-VITON. The link is here, and the site looks like this right figure. It has the source files with data processing, and GMM training, which is the first network, and TOM training, which is the second network, and results visualization with TensorBoard. During replication, we had several problems. Firstly, environment setting. Source code had outdated libraries with torch 0.4.0. So we needed to copy with the recent version with this specification. And during version upgrade, we did code modification to resolve bugs. Also, it had non-refined data. Thus, we removed non-refined data manually, 5.5% of 16.3K dataset. It included ground cloth data, which is not plain cloth image, and tilted cloth viewpoint, although we need frontal view cloth. And finally, round cloth model pairs, which means same index, but wearing different cloth. Next presenters will explain our replication results and plan for improvements of term project.
These images are results from the paper and our replication result. When you compare trion images from the paper and our replication, we can confirm that the performance of replicated code is comparable to the original paper. We define 3 problems to be solved from our observation and related work. First issue is an excessive distortion of closed images. As it is shown in the figure, some warping results are too much exaggerated. The second issue is occlusions on closed regions. In the figure in the middle, the network perform improper warping on closed image because they do not consider the region occluded by the human scale. The third issue is performance of GAN itself. The generated images from GAN has artifacts when we investigate those images. It is not difficult for us to distinguish generated images and real images. By referring existing works, we attempt to solve the aforementioned problem. We will apply new laws, namely grid interval consistency laws, to restrict unnecessary warping in cloth. We also apply human passing data in order to consider the regions of clothes uploaded by the other body parts. Lastly, we try to improve general performance of generated images from GAN. Specifically, we implement the refinement layers and attach discriminator after GAN, generally enhances the performance of GAN.
Okay, now we'll talk about the plans for our improvement. Our team members will do ablation study on each section, dividing each section and then testing separately with a baseline. Wonjung will apply the grid interval consistency and occlusion handling concept. Sunchen will implement the GMM-TOM discriminator along with SN-GAN. Yujin will implement the refinement layers on TOM and evaluation metrics. Now, you can see the schedule for the future plans. First, the implementation on each part will be done on the following week. Then on week 2, ablation study on each section will be done. Third, all tasks will be integrated into one, and final evaluation will be done with the original paper. Then with the results, documentation on the experiments and implementation will be written. Now, both qualitative and quantitative evaluation will be done on this project. The comparison of original results and ours, as you can see from the figure, these will be done as qualitative evaluation. And for the quantitative evaluation, we'll use methods like inceptive score and Frechet inceptive distance, which are widely used metrics to measure the synthesizing performance of GAN, which is used in our network. It is to determine whether the synthesized image dataset is statistically similar to the real dataset. Today we've shown you our progress on virtual try-on, and if you have any questions or further idea, feel free to leave your comments here on YouTube. Thank you for your attention.